Hi friends, welcome back to Chetu Text 247. Today we will discuss about some Unit 3 important questions. I have picked up very most important questions, around 24 questions. With these 24 questions, we can complete the entire Unit 3. So we'll discuss one by one with detailed explanation. So let us start with first question. Define functional dependency, explain types with examples. Functional dependency means we can write it as if let us take x comma y are two relations, then if x determines y or y is dependent on x, that we will call it as functional dependency. Okay. And we have some of the types, roughly six types we have. We'll discuss about them, but we will prepare a notes, not this rough writing. Rough writing. We'll see the we'll copy this question and we'll see the answer. Okay, this is the question. So let us see the answer. What is functional dependency? If x and y are the two relations, then if x determines y or y is dependent on x, is called as functional dependency in simple. Okay, don't make it lengthy. You can write like this for functional dependency. Okay, so what are the types? Types, let us see. The first one is transitive dependency. Second one is full. Third one is partial dependency. Fourth one is trivial dependency. Don't worry, we will see all the definitions with examples. And non-trivial dependency. And last one, multi-valued dependency. Okay. One, two, three, six we got. So there are six types. Okay. Let us see each one. One thing we will discuss, we will discuss. Let's coming to transitive dependency. Here I will write if A, let us take XYZ, uh, our relation R contains X comma, Y comma, Z. The transitive dependency means X implies Y and Y implies Z, that is equal to X implies Z. Okay, see, if X determines Y and Y determines, sorry, here Z, Y determines Z, then automatically X determines Z. This is called as transitive dependency. Okay, now going to full dependency. Full dependency implies if X is the, we know that the primary, okay, primary key. So if X is the primary key, then all the attributes X, Y, Z, X, then Y, Z should be dependent on the X, both. Okay, so X determines Y and X determines Z. This is full. Then partial. Partial means if X is the, as I told, X is the primary key or the candidate key. A primary key or candidate key means which identifies the all the records within the relation uniquely. Okay, it is called as candidate key or primary key. So partial means if X depends on Y and X determines Y and uh, Y determines Z. That is partial. See, as I told, X is the candidate key or primary candidate key or primary key. Uh, Z and Y both should depend on the X, but Z depends on Y. There is no relation between what? Z then X. So it is partial dependency. Okay. If Z depends on X and automatically Y depends on X, then it is full. Here I told. If not, partial. Okay. Make a note that this is most important partial. Then further we will use that. Trivial means simple logic. Whatever, whatever the attributes present in the LHS should be present in the RHS. Okay. That is, see, for example, if we take example as if, sorry, X determines, XY determines Y. Okay. That is whatever are there in the LHS, whatever are there in the RHS should be in the LHS. Okay. Here Y is there. So here Y also there. Whatever it is within the combination, the RHS should present in the LHS. This is the rule for trial. Non-trial based, you can guess. But if whatever present in the RHS is not present in the LHS, then see Y we have written, and here if we write Z, so it is not trivial because Z also is present here. Okay, if write Z here, then it is not trivial. So it is not trivial. Whatever the LHS should not be present in the LHS. That's the example. So these are the types, and last one multi-valued. Multi-valued means if mm, we can say that if X determines Y, okay, and see multi-valued means every attribute in the RHS should depend on the LHS, but there must not be any relation between Y and Z. Okay, then it is multivalued. See, once again I will repeat. This both Y and Z should be dependent on X, but there is no relation between Y and Z. Then it is called as multivalued attribute. Okay, this is about the first question. Now we will send the notes, and second question we will see. Explain one minute for the so suitable examples. Okay, with suitable examples, we'll see this answer. Okay, first basically the 1NF, 2NF, 3NF means these are the types of normalization. Okay. What is normalization? We will see now. Directly, if I say that its types, you may not understand properly. So, what is normalization? Constructing or building a well-defined, well-defined relation schema with no duplicates. Okay. Of the given relation is called as normalization. Okay, now you can understand the types. Okay, constructing a well-defined relation schema without with no duplicates of the given relation is called as normalization. Okay, now we will see the types. Um, types. Types of first type is 1NF. 1NF means there are no multi-valued attributes. Okay, multi-valued attributes means as I told before, the X should the I will explain here also once again. See, multi-valued attributes means single attribute will have multiple data. For suppose you will take roll number in the student table and name and qualification. Okay. For suppose roll number is 1 and name is Sai. If you take B.Tech, M.Tech, these are these qualifications. See, for one person, we are having two qualifications. That is, this is called as multi-valued attribute. Okay, this is the attribute of named as qualification. In this, it have multi-values. That's called as multi-valued attribute. So we should remove them. Okay, there are no multiple attributes. It's called as one and n. Okay, as a one example, you may write by keeping the pause of the video. And we'll go to without NF, we'll go to 2NF. 2NF means it should be in 1NF and make sure that it does not have what partial dependency. Okay, dependency. This is the most important thing here. Should not have partial dependency. What is partial dependency? Here, there. X is the candidate key, which it identifies uniquely all the attributes within the relation with X, Y, Z. So both Y and Z should be dependent on X, that is full. If not, that is partial. Because Y depends on X, but Z does not depend on X. It depends on Y. Okay. Here's the example. You may write it down, no problem. Here only. Okay, this is the example. Next, going to 3NF. Going to 3NF. It should be in 2NF and make sure that it is free from transitive dependency. Okay. It is free from transitive dependency. Transitive dependency means here we know that first one, this one. Okay. There is no need to explain again. You know that. And next, second question, with sort of examples also they are given. These are the examples. So without any doubt, we will go to the next question. Third question. What is 2NF? Explain partial dependency with example. Okay. This is only the third question. Same. 2NF and partial dependencies like this. Okay. These are functional dependencies. We call it as. They are given the question. Don't worry. What is 3NF and transfer dependency? With example also we have seen. Define BCNF. How it is different from 3NF. Okay. We will see this. This is the most important question in the semester exams. So this question. Define BCNF. So we will see the answer now. BCNF means abbreviation is boycott, boycott, normal fault. Okay. Now we will see the definition. Um, LHS site must be a super key. Okay. It is more stricter than 3NF. Okay. It is a normal technique. Okay. This is about the boycott normal form. We'll shortly call it BCNF. And it can also be called as 3.5 NF. That is 3.5 normal form. Okay. 3.5 normal. That is. This is about the BCNF key. Here the major thing is super key. Okay. What is super key? We will see it about super key. Super key. What is super key? It is a subset of all the keys formed with the candidate key. Okay. That is for suppose we will take an example. Example is if AB is the candidate key, then super key is if we take the relation as A comma B comma C, then the super key is A B C comma B. Then AB should be compulsory there. So if we take A B C D, then we can write more than one. A B C and A B C D. Make sure that it should also these leave and today. These two should be also uniquely identify the attributes within the table. Okay, then only these will be super keys. If not, these are not super keys, even though the candidate key is present. Okay, this is an important note point. Once again, I will repeat. See, even though we have candidate keys combination also, this must be uniquely identify the records within the table. So how to check is find again the closure of ABC. Okay, closure of ABC if we find we will get that. This is closure. Closure how to find you know that I think you know. Let us go to next question. Explain our first step-by-step example. Okay, again we will discuss. I have discussed the normalization definition, so we will discuss about the steps in it. Okay. Yeah. Steps. First step is make sure that relation is in 1NF. Then convert it into 2NF. Thereafter, 3NF. Thereafter, 3.5 NF. Okay. This is the procedure should be followed in the normalization process. So why do we do normalization? Because to get it simplified structure and free from duplicates. Okay, free from duplicates. That's it. That is about the normalization process. You can elaborate by writing the definitions of 2 and F3 and F3.5 based upon the marks criteria. Next, explain decomposition, which is most important. We will see now clearly. Explain decomposition. So we'll go with the decomposition once first. Decomposition means, see, decomposition means verifying whether the relation is lossless or lossy. Okay. Uh, to know that, we will check what is lossless. We will try to learn about lossless. Lossless means there in question they will give some FDs. FDs means functional dependencies. For them, we should find the unique candidate key that is, and find the newly formed FDs. From there, they will give two relations. Okay. Then next step is we should find, for suppose R1 is one relation and R2 is another relation. So for this, we should find R1 union R2. Some FDs will get in this if these FDs are present in all should be present. All should be present in the relation what relation R FDs. Then it is said to be in lossless process decomposition. Okay. Otherwise, what happens? Lossy decomposition. That's it. This is about the decomposition and lossless and dependency preservation. Dependency preservation means we should make sure that whether it is in the lossless or not. If lossless, then it is equivalent to dependency preservation. Okay. The major steps are find union to the two relations R1 R2 and then check whether those are present in the main relation or not. That's it. What are the guidelines of? Okay, we will discuss about the guidelines. Simple, these are. We can get 2 marks, expect 2 marks question. So there are basically there are four guidelines which are most important. There are four guidelines. So GD means guideline. G1 we will take. G1, the attributes must be semantic. Semantic means meaningful. Okay. Next, guideline 2, there must be avoided null values if required use. Okay. As soon as we want, we should avoid the null values. Okay. Next, guideline 3 is the anomalies delete, update. Okay. And we will take delete, update, and anything. Insert. Like this, some of the anomalies are there. Anomalies means the difficulties or problems occur when we want to delete the particular data. If it is not present in it, we will get a anomaly. So make sure that these operations, if there is any need to perform these operations, that specific property should be present in the table. Like if we want to insert that column should be, if we want to insert the age column, age data, there must be age column within the relation. Okay, if not, it raises an anomaly. That is the meaning of G3, of the guideline 3. And guideline 4 is very, very important. Guideline 4 is there, okay, use of joins to eradicate or decrease the null values. Okay, so this is about this question. I will move to next question. Give a relation and this highest common form and highest common form will the practical part next. Relation theory for becoming the decomposition give question. These are all questions. One example we can take. Actually, I am listening. Just now we have discussed. That question we will do. Okay. These are all questions we will see in the next video. These all are the practical part. So we will see in the next video. Stay updated with our channel. Please like, share, and subscribe the channel.